I'm your chemistry tutor, and good morning, everyone. And today I'm going to teach three important topics from Chemistry Unit 1, which is matter, measurement, and data analysis. So, these are the first concept every chemistry student must understand. Because we observe matter, we measure it correctly, and then we analyze our data to understand patterns. So, I will explain everything clearly with simple examples. So, what is matter? Matter is anything that has mass and take up space. So, for example, like the desk, water, air, metal, your phone, all are matter. So, let's go to like a state of matter. So, there are three different types of state of matter, which is solid, liquid, and gas. So, solid is like has a fixed shape and volume. So solid will be drawn like this. It does not have any gaps. Solid is drawn like this. So solid is like a particles vibrate but do not move past one another. So the second type is liquid. Liquid is particles are tightly packed but are able to move past one another. So it's like a little bit gap in it. So liquids are particles are tightly packed but are able to move past one another. So let me move to the gases. Gases are the particles are very far apart from one another. So it's like this. Makes so much gap. Which is particles are tightly packed. Particles are very far apart from one another, which is gas. So this one is solid, and this one is liquid, and this one is gas. So for example, solid is like ice, wood, or iron rod. For liquid, it's like water, milk, and oil. For gas, we could consider as carbon dioxide or oxygen. So let's say the characteristic of the three types of state of matter. So for gases, it fill any container you put in. Gases expand to fill the entire volume. So if you fill any container you put in, it will fill any container. So the next one is like particles are arranged randomly, and the particles move in constant random motion. So gas particles move fast in all direction, and gases has mass. So all matter has mass, including gases. So particles are spread far apart from one another. So gases particles have large spaces between them. And for the next one is liquid. So liquid is like particles are arranged randomly. So liquid do not have like an ordered pattern like solid. So liquid also has mass and flows from one container to another. So liquids can flow. So particles are arranged somewhat close together. So liquid particles are close but not as tight as solid. So, so let's move on to the solid. So solid or particles are placed very close together. Solids are tightly packed, and it has mass. All matter has mass, including solid as well. And particles are arranged in an organized way. So most like solid has a fixed order structure. And let's move to the classification of matter. Let's move to classification of matter. So classification of matter, we have to learn about the pure substances. Like number one is element. So element is like a one type of atom, for example oxygen, Fe or Au. So compound is like two or more element chemically combined, like for example H2O, sodium chloride and carbon dioxide, like that. So this cannot be separated by physical methods. So let's go to the mixtures. Like mixtures is like there are two types of mixtures, like homogeneous mixtures and heterogeneous mixtures. So homogeneous mixtures is like a uniform through it. For example, like salt, water, or air. For heterogeneous mixture, they are not uniform, like sand, water, or salad. So let's move to the properties of matter. Properties of matter is like a physical properties like color, density, or melting point. For example, ice melt at 0 Celsius. For chemical properties, it's like flammability, ability to rust, or like example, for example, like iron rust in oxygen. And let's go to the change in matter. Change in matter like a physical change and a chemical change. Physical change is like no new substances, like for example like cutting paper, melting ice. For chemical change, like new substances forms, like burning wood or rusting. And for measurement, it's like let's go to the next part, which is measurement. So measurement is like when you do length of the something, length is also called meter. Length is meter. So, and mass is kilogram. We should actually call kg, and temperature is called Kelvin, and time is called seconds. So let's move to the accuracy versus precision. So accuracy is like a closeness to true value, like expected, for example like expected like 5 grams and you get like 4.99 gram, which is like accurate. But precision is different. It's like repeated values are close to each other. So for example you get 4.10 grams, 4.10 grams and 4.11 grams, which is precise. You can be precise but not accurate. Significant figures. So significant figures has 4 rules. So it has non-zero digit count, like 45 has 2 significant figures, and zeros between number count like 405 has 3 significant figures, and leading zeros don't count 0.0045 is 2 significant figures. So trailing zeros count only if decimal present, like 4.500 is 4 significant figures. For dimensional analysis, for example, so we have to convert 9.53 meter to millimeter. So we know we have to convert meter to millimeter. So 1 meter is 1000 milliliter, right? So 1000 milliliter. So we have to make like this, like chart. So 9.53 meter would be like this, and we know 1 meter is 1000 milliliter. So meter and meter will be cancelling out, and we have to multiply this 2, which is 9.53 times 1000 will be giving me 9000 and 9530. This is my final answer. So meter and meter, so we have to convert it to millimeter, right? So meter and meter will cancel it out, and we left with 9.5 times 1000, which will be giving me 9530. So if it has like, let's say like 10 meters and like 100 something like that, and we have to cancel meter, and we have to multiply this 2. Let's say if it has like a meter over here, which is like 2, and we have to multiply this 2, and we have to divide by 2. So multiply this 2 and divide by this. So when we multiply this 2 and we divide by like 1, which will be giving the same answer. If like 2, then we have to multiply by 2. So for scientific notation, if it has 0.000045, I could do that by 4.5 times 10 to the power of negative 4. Okay. So this is given, so 0.00045 will be written as 4.5 times 10 power negative 4. So we have to take the decimal place and move to the 4.5. So 1, 2, 3, and 4. So and we have to make it 4.5, which is 1, 2, 3, 4, and 4.5 times 10 to the power negative 4. So the next example is 3, 2, 0, 0, 0, 0. So we are going by here. So 1, 2, 3, 4, 5, 6. So 3.2 times 10 to the power of 6. I get the 6 by doing this 1, 2, 3, 4, 5, and 6. So 3.2 times 10 to the power of 6. So let's move on to the data analysis. So chemistry relies on data to understand what is happening in experiment. So let's start on density. So density, it tells you how much mass is in the certain volume. So density, so the formula for density is mass over the volume. So for example, if mass is, let's say if mass is 10 grams and the volume is 2, so the density would be 5 gram milliliter. So let's move on to the percent error. So percent error is like shows how close your experiment value is to the expected value. So the percentage error equal, the percentage formula is absolute value experimental value negative expected value and close the absolute value divided by accepted value times 100. So let's say like small percent value, there's like small percent error is good accuracy and large percent error is poor accuracy. So there are types of data. So qualitative data and quantitative data. So qualitative data is describes using words, not numbers. So for example, colors, smell, and textures. And quantitative data is uses number, for example, 12 grams, 25 milliliters, 50 Celsius, like that. And for graphs and variables, in graph, independent variable is x-axis, the thing you change, and the dependent variable is the y-axis, the thing you measure. A graph can show trend like increasing, decreasing, or constant. For like there are like two different relationship, like direct relationships and inverse relationships. So direct relationships is like both values increase together, like heat is decreasing and the pressure is also increasing. But inverse relationship is one increases while the other decreases. For example, distance is increasing and the gravity is decreasing. For the percent error, you have to put the accepted value and the experiment value to the blank thingy, and we have to times 100 to get the result. And today we can cover the matter, measurement, and data analysis. So matter explain what things are made of and how they behave, and measurement teach us how to collect information accurately. And data analysis help us understand and interpret results. So these three topics form the foundation of chemistry and will help you in every future unit. Thank you so much.